and welcome to That's Absurd, Please Elaborate. I am Trace, one of the two hosts of the show. Julian is actually out today because he is doing something with NASA, which he did not invite me to, and I'm not mad at all. I'm a little mad. But we have a guest here with us today, Matt Krol. Hi, Matt.
Hi, Trace. Hello. How are you?
I'm good. Matt, can we tell everybody, where you're from? What's your thing?
Sure. I'm Matt. Pronouns he, him. I am the showrunner, narrator of Extra Credits and Extra History over on the YouTube machine and, of course, on Nebula. With shorts out, I can't really call them short form anymore, though we're doing those as well. I'd say roughly 10-minute videos that are all animated where you'll see a little cartoon me talk about things like history, mythology, literature, and video game design across both channels. That's kind of my jam.
I love it. Yeah. And so we've met several times, and I thought, well, if Julian's out, let's have a guest come in and we can talk about some absurd questions.
That is absurd, and I cannot wait to elaborate. Actually, what I want elaboration on very briefly.
Yeah.
So do you, and you don't have to answer what this is, do you know what Julian is working on at NASA right now?
Yes,
okay,
I do.
Okay. Can I, wrong answers only, guess what Julian is working on?
Yeah.
Okay. Boots that stay tied in space.
How did you guess first out?
Oh,
right
well,
out of the
there we
gate?
go.
You got it.
I figured it was going to be some Back to the Future-ish.
I thought you said wrong answers only, but there you just nailed it.
All right. Well, good. Well, I hope everything's staying nice and tight over there.
They're high and tight. That's how they like it. High and tight. If you've never listened to this show before, by the way, audience, hi, welcome back to the conversation.
Hello.
This is a show where we get questions from the audience, and we use our years of science communication and just desktop research and or, amateur journalism to try and answer those questions. Sometimes it's funny, sometimes it's stupid, but we do our best, and we can't do this without your questions. So if you have a weird, absurd, off-the-wall, or outlandish question, head over to our website, that's absurdshow.com/ask, and put it in. You can also look in the show notes, or, you can always email us or send it to us, however you can find us on the social medias. With that, I think we should get to one of our absurd questions. Matt, we didn't talk about this before. Do you want to go first? Or you want me to go first?
I have a question. I want to do my question first because well, not the question that I'm answering, the question that I'm asking.
Perfect.
Right?
Yes.
Because I've listened to a bunch of your episodes by this point, and I don't want to say I'm the least scientific person that you've had on, but one thing that, especially in the video essay space and in kind of what we all orbiting, especially in the Nebula community, et cetera, sort of do is we pick something that we're very interested in and we go hard and try to research it and talk about it and just dissect it from as many different levels. For me specifically, it's history with my very talented writer Rob Rath on that channel, and video games with Jeffrey Zadkin and James and all of them over at Extra Credits. So while I am not in the pure science research thing, I am very much in the let's go into the minutia of whatever we are talking about. And this particular question, I have personally not looked more than a tertiary thing because on my initial searches, it was always very like it could be a bunch of things. But I always thought the question was so simple and silly that I couldn't get a silly or just a non-silly simple answer to. And that is, why is ice slippery?
Perfect. Yes.
Because I've heard, look, it seems on the surface, no pun intended, there's bunch of different reasons why this could be. But every time I looked up one, and I'm so curious what you found, I hit a wall of like, it could be this, but it's not. And I'm like, okay. So why, Trace, why is ice slippery?
This is a great question. And when we were talking about, you could come on the podcast because the question that you're going to answer later, without giving it away early, is right in your wheelhouse.
Yes.
And we're like, well, we do the science-y things, and this isn't really our thing. So we need a person who does movie things in order to answer it. So that is why we're so excited to have you. So this is going to be a nice hybrid episode. Okay, so why is ice slippery? I loved this question because it hits it's like the perfect That's Absurd show question.
Right.
Because it seems simple, but it's not simple, which is awesome. So this is a classic question in the world of science, like clearly. This has actually been asked, not just by you, Matt.
What?
Don't you worry. This is something that's been asked for a while. Surprisingly.
Yeah.
So there are all these different people who have researched it over the years. And I'm going to start by explaining something called Le Chatelier's principle. It's about dynamic equilibrium.
Okay.
It's a great band name, by the way.
That is. That was in my prog rock band in college.
Yo, you going to go see Dynamic Equilibrium tonight? Yeah, I would go see them. Basically, if something changes in nature, the substance will shift to restore equilibrium.
Okay.
Right? So if you make water hotter, it's going to have to move by expanding. It's going to, essentially energy is contained within it, so it has to change. In physics and chemistry, that could be a relationship between all sorts of different factors. So it could be pressure and temperature. It could be volume and mass. It could be all four of those things. Right. A good example would be like if you squish something, you're adding energy to it, and so it has to change either by increasing its volume or increasing its temperature or both because it has to restore its equilibrium.
Sure.
Maybe it breaks, like if you put pressure on glass, it has to break because it needs to restore that equilibrium and release that energy.
Right.
So that is the basis that we need in order to understand why ice is slippery. I know that sounds like we're getting like already high and excited about it, but I want to also say something not everybody knows about me that I'm going to share with you, Matt.
Okay.
I'm a blacksmith.
What?
It's just a hobby that I have.
Wait, how have we not talked about this before?
Yeah.
I am so interested in that, and part of it comes from my sort of like RPG, tabletop, D&D background, just because, weapons and swords and things.
Yes.
But other things, my dad is a craftsman, and not a blacksmith specifically, but he is just a builder. Do you have like a forge in your domicile?
Yeah, in LA, I don't have one, but my plastic grass in the backyard wouldn't lend itself well to that. But I'm hoping at the next place we live, I'll be able to finally have like a little spot with a forge and some steel and some coal.
Hell yeah. One day I hope to at least own a fork and a knife that you have forged.
I have never made a fork.
No? That's like the first thing that all of my friends that ever got into blacksmithing sort of made as like their trial product was a fork and a knife.
I definitely have made a knife. That was something I was like, I got to learn to make this. So fun fact about blacksmiths, they don't typically make things that aren't considered like tools or hardware.
Right.
Apprentice blacksmiths make nails a lot.
Yeah.
Like if you think about how a nail was made prior to the invention of automation, you had to like essentially take a piece of steel, usually a piece of, quarter-inch round stock or something a little thinner. You essentially hit it twice. If you're really good and you have the right hammer, you can make a point on it, and then you knock the end off of it, and make a head. And that's it. You can do that, like a good blacksmith can, I can't remember, it's something like 50 nails an hour.
Sure.
Which is like a nail every minute. It's pretty wild, almost. And so I'm not that good. I like blacksmithing. I think it's fun. It's relaxing. You kind of turn your brain off and just see what the steel does. But it's neat because it's a mix of fire science. It's a mix of pressure and temperature, volume and mass. And the reason I bring it up is because the first time people thought about ice being slippery, they knew some of these basic principles of matter and how it behaves. If you take two iron bars or steel bars, each about an inch or 2.5 centimeters, and you took two sledgehammers. So if you and I were in a forge and we did this, we would heat up those iron bars in the forge. We'd put them on the anvil with two assistants, and the two of us would hit the ends of them with a sledgehammer, and we can fuse them together. Like those two little guys in Zelda Link to the Past, that you have to help.
The two brothers that are going back and forth to help you forge the Master Sword?
It's literally that.
I was literally writing a script that talks about Link to the Past today, so this is all very connected to me.
Perfect. I love it. So that is exactly how you would fuse two pieces of metal in blacksmithing. I've done this. It's awesome, and it makes you feel really awesome when you hit it for the first time and all this like glowing stuff flies everywhere. Anyway.
Nice.
If you're hitting it at a quick enough pace, even just you and me, Matt, if we were hitting it like boom, 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 the steel will not cool off.
So even if we were hitting it at the pace of Peter Gabriel's song Sledgehammer, right?
That might be too slow.
Would that be too slow? Oh, dang. Okay. All right.
It depends. Are we hitting it like, I wanna be your sledgehammer?
I feel like it's more on the...
I think that's too slow.
I think it's like, I wanna... sledgehammer. Yeah, I think that's kind of like...
I think we could do that.
All right.
Yes. Yeah, that would probably... That's important. It's important. So I have done this in a blacksmith shop.
Okay.
We fused this piece of steel together to make andirons, which are the things that hold logs in a fire.
Right.
I worked at a historic site, so we were doing it there, so we couldn't make like modern stuff. We made a lot of historical stuff.
That's so cool.
It was really fun. It was a great college job.
I love that.
But when we were doing this, the steel didn't cool off. Typically, even in movies, you see like blacksmiths and they're hitting essentially cold steel, like it's not glowing.
Yeah.
Most blacksmiths would see that and they're like, this is awful. It needs to be glowing in order for you to mold it. Otherwise, you're just hitting cold steel with a hammer, which isn't good for the steel or the hammer. So when you see steel, it's supposed to be orange. I swear this all will make sense in a minute.
Because we are talking about ice, just to remind the listeners.
That's right.
Yeah. Okay. We're going to get there.
So while you're squashing the steel, it actually needs somewhere for that energy to go, the energy you're imparting to it. So what ends up happening is it heats up. The atoms inside the steel are heating up, and you can keep steel hot for a long time just by continuing to press it and hit it with these hammers, where typically it would cool off pretty quickly. It's a really cool thing to experience if you get the chance. But the reason I mention this is because the common knowledge answer, if you were to just go out and Google it, I've even said this in videos. Back when I did D-News, I have said this in a video, that the pressure of the person on the ice, like a skater, for example, causes local melting under their skate, and that is what is slippery. Right? The pressure heats the liquid on the top of the surface of the ice, and then as you skate by, it freezes behind you. And so that, unfortunately, is not correct.
Right, because I look, and again, what I've found for this question in a much more layman style than what you've just described was like, that was the first thing that they thought. But then they took measures in experiments to like remove certain elements of that equation to see if it would still be slippery, even though they've equated for that, and it still was slippery. Right? Is that what they? Yeah.
Honestly, you're the perfect guess.
Okay,
that is totally true.
Great.
So it's more complicated than that. So this was first studied over 150 years ago. So 1850, this guy named James Thomson created a formula to understand how ice and pressure work together. Essentially, like the inverse linear relationship between freezing point of ice and the pressure that ice is under. So basically, the freezing point of ice goes down if you have a higher pressure, and it goes up if there's a lower pressure. So if you're trying to freeze water in like a pressurized container, it can stand to get colder before it turns into ice.
Right.
You have seen this. It's like a viral video on YouTube where you like put it in a water bottle and you put it in the freezer and then it's still liquid until you hit it and then it like turns into ice immediately.
Yes.
You're changing the pressure. Like that is exactly what James Thomson discovered. Now we just TikTok it. But either way.
Where the real science happens.
Exactly. A few years later, a guy named Michael Faraday guessed exactly what we were just talking about, where like the skates or like the pressure on top of the ice then must make local melting, creating a thin layer of water. We all know that water is slippery. You put it on any hard surface, it's going to help you slip and fall down because liquid molecules just move around. And he was like, pressure doesn't really matter. There's just this layer of water on top that's not frozen.
Right.
That wasn't really right either.
Exactly.
And they're trying to figure this out. A guy named Lord Kelvin, who's a British mathematician, also in the 1850s experimented on James Thomson's theory of ice and pressure and figured out that it was correct. We know it's correct today because, again, TikTok and water bottles. Then by 1886, a guy named John Jolly combined these ideas together to figure out local pressure results in the skates melting, which again is where we get into this like modern day. Oh, well, clearly it's melted ice because under the skate it's melted and it's slippery. However, exactly to your point, people started experimenting with this. In the 1880s, it's hard to make ice. So into the 1900s, we start getting good at making ice. We can try out things.
We're no longer importing ice from places. We can now make the ice more readily at a consumer level. Well, more of a consumer level. I know that comes a little bit later, but still.
Yeah, but by the 1940s, 50s, when we're doing a lot of these experiments, they're like, wait a minute, this doesn't hold up. If the ice is really, really cold, even if it's super cold outside, it's all of a sudden not slippery. And in fact, ice itself is not a slippery substance.
Yes, that's what I've come across too. Because the molecular build of it or whatever is actually quite rough.
Yes. Yeah, exactly. And even water is just a weird thing. Like, that's actually what we're going to end up talking about here, is that water is just weird. It's super weird. But before I get to that, let me wrap up what one of these experiments found. Kenneth Chang wrote in the New York Times in 2006, a 150-pound person standing on ice wearing a pair of ice skates exerts pressure on the ice. If it were just pressure causing local melting, it would have to be a lot of pressure, because a typical blade edge, which is not razor sharp, is about 1/8 of an inch wide and about 12 inches long. That yields a surface area of 1.5 square inches, or 3 square inches for 2 blades. That's like a handful of centimeters. Sorry, Europe and everyone else in the world. Either way, that raises the pressure and lowers the melting temperature of ice from 32 degrees to 31.97 degrees. So it can't be local melting.
Yeah.
It just can't be. It's not enough pressure. You have to put it under ridiculous amounts of pressure in order for it to be able to locally melt. And then, like, what happens? Immediately after the skater goes by, there's water behind their blade that immediately freezes. That doesn't make sense, and it would be easy to see, especially as we get to high-speed cameras, and we can't see any of that. So people were just like, we don't know. It just ice is slippery. It just is. Just deal with it.
Just putting a quick pin in it for a second, just in your research in scientific topics, do you often find that there are spans throughout history or even things today where the research gets to a certain point and then people are just like, no, I don't even care. I don't care. You know what? This is someone else's problem 50 years from now. Like, does that happen a decent amount?
Oh, yeah. All the time. All the time. I started working with somebody back at D News, and he was like, we sat in this meeting and we were talking about something, and he goes, I thought science knew everything. This is so weird. And I was like, what do you mean, Brian? And he's like, I thought they knew everything. And the more I do this job, the more I realize we don't know anything. And I'm like, you're right.
Science.
We don't. Science. Yeah, that is exactly, Matt, what happened here. People were like, look, we don't know, but it works. So ice is slippery. And that was sort of the common knowledge answer of like, oh, well, local melting is probably it. Or like there's some water on top of the ice, blah, blah, blah.
Close
and
enough.
That was just... Yeah, they're like, we're in the ballpark. We're close enough to the answer.
We gotta go to space now.
Yet.
This is not. We don't care about this.
Yeah, they're like, look, we got Nazis coming. We gotta go to space. The internet has been invented, and now we don't care.
A lot going on.
And there's a lot happening in the 20th century. They continued to experiment on water and other compounds. And like I said, water is weird. Matt, how many types of water ice would you say there are?
Oh, God, Trace, I don't know, man. So my grade school level education would say 1, but I know that's not true.
Mainly because I'm asking, even like you just deduce.
I'll give a ballpark.
Yeah, sure.
14.
Honestly, at some point in recent history, you would have been correct.
Huh.
Now it's 20 or more that we know so far of different types of water ice.
Okay.
Basically, they're completely different types of ice that all exist at different pressures and temperatures.
And does that change sort of the way the molecules lock to, and I use lock loosely, but like go together in what shapes that they create?
That's exactly correct. Huh. Yeah. So water is weird. It's a chemical compound that's liquid at like normal temperatures for us. It boils into gas and freezes into a solid in a pretty like small window.
Very close
Like if you think
window.
about it, 100 degrees Celsius is relative to the entirety of temperature in the universe is nothing. That is
nothing.
No amount of temperature. And so it's like it seems counterintuitive to think about it that way, but water is super weird. It's rare to have something that would do all 3 of those phase changes in such a small window. Great for us, obviously. We need it for life, but...
big fan.
But still, yeah, super big fan of water.
Water is the Taylor Swift of chemical compounds.
Wow. It really is. You could say it's the problem.
Yeah.
It's me.
Yeah.
So it forms all these 20 different types of ice. And they have all these different names. It's actually, there's several ice ones. So ice phase 1 is typically considered a hexagon-shaped ice crystal. If you think of snowflakes, that's ice 1. If you think of ice like at an ice rink or in your fridge or whatever, those are all ice phase 1. Basically, you cool it to a normal cool temperature and you get ice.
Sure.
However, if you put ice phase 1 under pressure when you're trying to freeze it and cool it to an even colder temperature than you would find normally, so like
you put it next to David Bowie.
Yeah,
sorry, everything I'm going to do is references to music, and I apologize already.
Yeah, you get Freddie Mercury on one side because he's very dense, and you get David Bowie on the other side because he can be very cool.
Yes.
And then you get ice phase 2. It was discovered in 1900. Basically, you cool it to negative 75 Celsius, 103 Fahrenheit, negative 103, and you put it under 2,900 times the pressure at sea level. So this is like found in space. It's not found on Earth, unless you build something to do it. So the crystals in the ice completely reform into rhombohedrons, which is like a 3-dimensional rhombus, like a parallelogram that's, like a house that's slanted over. And these probably exist at like the core of Jupiter's ice moon, Ganymede. It's really neat. It doesn't do anything too wild, It's not like these are super useful types of ice. It's just cool that it does it. So then we have ice phase 3. You get tetragonal crystals, which I'm not even going to try and describe. And that is actually a bit warmer, weirdly, than ice 2, negative 23 Celsius or about negative 10 Fahrenheit under the same pressure. And there, again, are 20. I'm not going to do all of these. Matt, interject at any time here.
No, what's number 4?
I was going to say, here's number 5.
Oh, okay, let's skip 4.
Ice 5.
No one gives a crap about 4.
Well, 4 is cool. It might be useful for fuel cells. It has a proton conductivity, which is pretty neat. Ice 5 is similar in temperature to ice 3, but it's got a higher pressure, and the crystals become monoclinic. I don't know what that is, but it looks like a crystal from a movie. Like you picture a crystal, and it's like kind of a cylinder with like cool sides and like a little point on the end. That's what it looks like, but it's tiny little ice crystals.
We have to construct additional pylons.
Yeah, exactly. Yeah. Yes. Or you need to hack into a Goa'uld spaceship, and for some reason they use crystals in their little drawers, which is really useful. We used to keep DVDs in those, but hey, you can keep crystals and run your whole machine on that.
But now science is on TikTok, so we've had to move forward.
So there's also ice 7, which is cool. No pun intended. It becomes super ionic, which is like a cross between a solid and a liquid. This happens at 1,000 Kelvin, or about 726 Celsius, 1,300 degrees Fahrenheit. This is warm
right,
ice.
But under so much pressure that it is still mostly a solid?
That's right.
Okay.
It's 400,000 times the pressure at sea level. And what happens is it's positively charged hydrogens, the H2O molecule, float around. They get off the oxygens and just float around inside of this oxygen lattice crystal. And it behaves like a conductive metal, but it's actually ice under a ridiculous amount of pressure. And also, in case you're wondering, it's been made at the Lawrence Livermore Lab in California, and it's black.
That is dope. Black. That is metal as hell. Like, I want to make like a fantasy role-playing villain that is based around Ice Phase 7 or whatever. That is, it's black?
It's black. And 4 times denser than regular ice. So even if it could exist with regular, like, water, it would sink in water because it's just super dense.
I love it.
And like I said, might behave like a conductive metal. Like you could just conduct electricity through it. But again, can't really exist at our atmospheric pressure.
Do you know off the top of your head or in your research how many of these types we've been able to make on Earth?
We know that a lot of them exist theoretically. I don't know off the top of my head how many we've made. I'm guessing that we've made most of them, and then we're figuring out, mathematically speaking, this is what should happen, and then we go and test it. But off the top of my head, I don't know if we've made all 20-some ices.
I wonder
on
too,
Earth.
like, and actually this is more of a general, when looking at things like this or changing, chemical compounds into different configurations, it is oftentimes in the research, and I'm just going to use the iced phases as the example, will they be like, okay, we've made ice 1, ice 2, ice 3, oh, this is a weirdly complicated one, ice 7. And then they'll be like, well, mathematically or theoretically, we can figure out what 4, 5, and 6 are? Like, do you get what my question is? Like, do they...
I get what your question is. Yeah, when you find elements, for example, and you find iron and you're like, this is pretty heavy, but you haven't found something lighter than iron.
Yeah.
And you're like, well, we got to fill this in. There's going to be 26 protons. There's going to be 25 protons. There's going to be 24 protons.
Again, sorry if that sounds stupid. I just don't know how this research works.
It doesn't sound stupid at all.
Yeah.
No, it doesn't sound stupid at all. In this case, it seems to me, and again, I'm not an expert in this area, but it seems to me they're naming them as they find them. So there used to be, when I did a D-News video about this years ago, they only knew about like 14 or 18 ices.
Okay.
And now we're up over 20.
All right.
So I think they just are naming them, oh, this is ice 20 now because we've discovered it now. So I think they're testing all of the low-hanging fruit. Let's put it under this amount of pressure and at these temperatures and see what happens. And they just do that over and over and over again.
Now, are they all slippery?
No, they're not. Yeah. In fact, even regular old ice 1 isn't slippery at like negative 100 degrees or something. It's only slippery at about negative 7 Celsius.
Okay.
Or about 20 Fahrenheit. And that's a great question because it leads me into how we know ice is slippery.
Well, I've fallen enough times in upstate New Hampshire to know that ice is in fact slippery. And I will say, though it's not phase 7, black ice, particularly bad for my body.
Yeah, it is. Ouch. I hurt myself pretty bad. When I don't fall down much, but when I do fall down, it's usually a doozy. And ice is not my favorite.
You had a real most interesting man in the world vibe there. Like, I don't often fall down, but when I do, it's ice.
It's ice. It's the fault of ice. Pretty much. So when I made my D-News video that I've referenced a couple times, I think it was 2014 or 15. It makes sense that I would have said, hey, local melting is probably what causes ice to be slippery.
Sure.
Because we didn't discover the answer until 2021.
And that explains why I have not found it myself, because every once in a while I'll find these questions and pick away at them. But by that point, I was so busy with extra credits, extra history, and the other thing, which I didn't mention, which will play into my question, the only podcast about movies, there's an asterisk in that title, which is a podcast I do about film. I'm researching all of these things. I don't know.
You're not looking
I
into
never
water.
even looked up the thing about ice again. 2021?
Yeah, 2021. Just a few years ago, they finally discovered what the heck was going on.
What happened?
And it has nothing to do with liquid layers. It has to do with friction. It doesn't even have to do, basically everything we've just learned about you can sort of throw away. It almost doesn't have anything to do with pressure or temperature. I mean, temperature does because it has to be ice. But it has to do with something called frictional heating.
I'm a little upset.
Right? I know. So were the scientists.
So
it's
is
great.
John Jolly and Lord Kelvin and Michael Faraday and James Thomson. They are all pissed. Either none of them are still alive, right?
No, they're definitely
Well, they're
not
definitely
alive.
angry wherever they are.
But who is alive is Rins Liffrink from the University of Amsterdam, who discovered it.
First of all, baller name. The last name is Liffrink?
Lieffferink. Liffrink.
So like rink, like as in ice rink.
Yeah, like an ice rink. I know.
Perfect. No notes.
And in Amsterdam, in case you're wondering, they wanted to know how they could make their speed skaters go faster.
Yeah, there we go.
The Olympics are coming up, not the winter ones, but still, they were working on it.
Sure.
So friction is a completely different thing than pressure, obviously. It's actually part of its own area of science called tribology. It's friction, lubrication, and wear, and how those things all play into each other. Any guesses who discovered some of the rules of friction? Essentially, like, friction is double the effort for double the weight.
To be honest, Trace, the second you said double twice, I went to mint gum. So I have no idea who.
Just a guy named Leonardo da Vinci.
Oh, that old chestnut.
That old chestnut. Go ahead and Google Da Vinci's doodle of an old woman.
Okay.
And for the listeners, we'll put this on our Instagram.
Okay,
so
cool.
If you look at the top, there's this like little doodle of this old lady with kind of a hooked nose. And this was, art historians looked at this and said, yeah, that's kind of cool. But then they sort of dismissed it. The thing below it, though, these little boxes were also dismissed by art historians for a while. But if you translate that writing, you get friction is double the effort for double the weight. This was 200 years before the guy who discovered friction and published about it in the Sciences had written this. So it wasn't until 1699 that Guillaume Amontons, who had been credited with discovering friction until like really recently, wrote friction is proportional to the force in which the object is loaded. And Da Vinci was all like, yeah, I knew that too in the 1500s. And this wasn't just rediscovered until 2016, which I think is awesome.
It's so nice
This
to
is
see
sort of a sidebar.
Da Vinci did more than just being Ezio's friend in Assassin's Creed 2. It's really nice.
I know. Isn't that nice? So helpful. And also Hudson Hawk's, helicopter.
That's
Hudson
wow.
Hawk's airplane ride. Without Da Vinci, how would Hudson Hawk have escaped that castle?
He wouldn't have. I'll tell you that.
He wouldn't have.
Yeah.
No song is going to... You can't sing your way out of this one, Bruce.
Nope. And we've done that on the podcast. We've done Hudson Hawk. It was a delight.
Such a good movie. But friction makes things harder to move. So Rins Liefrink in the University of Amsterdam took small little wheels and dragged them over ice, measuring the friction, the slip, the temperature, the pressure, all of these different things. And he did it in this like mechanical, computerized way. And he finally answered this question. Turns out when ice is at negative 100 Celsius or about negative 150 Fahrenheit, it's not slippery at all. It's super hard to get anything to move. It's essentially rough. But when it's near freezing temperatures, it is slippery. And the reason is ice freezes and melts in layers. So as it's coming to freeze, it freezes kind of like up in a layer, like an opera cake or a sandwich or whatever. And so the topmost layer of ice is either not quite frozen yet. So turns out John Jolly, Thomson, Faraday, and Kelvin were all sort of correct. There is a liquid layer at the top of the ice that's more mobile, but it's not really liquid. It's just surface molecules that are, quote, spread over the ice surface in a rolling motion. And you're literally sliding over these rolling molecules on top of ice.
So it's not that the molecules themselves are water. It is still technically in the build ice, but they are just a bit more loosey-goosey and sort of let you sort of flubber your way sort of like over it.
It is technically water, I guess. It's because it's all H2O, but it says a sharp skate on polished ice works best because there are fewer irregularities on the surface to snag and cause friction. Mm-hmm. So you're not slipping on like a layer of water. If you think about it as like a layer, you're slipping on the molecules that are on top of a rough patch of ice. So like there are just water molecules on there that haven't frozen into layers yet. They haven't found their crystals. And so you're slipping on just the molecules, which are pretty cool. So ice is not slick, but the molecules on top that roll around, those are slick. So if you have enough rough ice and a rough ice skate, you're just going to be able to walk around. Right? Which we intuitively know. You walk around in shoes and you can walk on ice if the shoe is rough enough.
Right.
And that's no big deal because you're not rolling around on the molecules. If there was water there, if it was a smooth surface with water on it, it wouldn't matter necessarily if your shoe was rough, right? You're not heavier, so you should just fall over just the same. It's only slippery if you can slide around on those molecules.
So I think the only thing that my brain is having a hard time wrapping around in this now proven scenario, thank you 2021, is those molecules that are on the top are sort of the ones that as the ice is building its structure, it's sort of the next layer that, if cold enough, will become the next layer of the ice, right? And it has to stop at a certain point because of a bunch of different factors. I'm talking about like specifically outside in the winter in the northeast of the United States, right? Like so those molecules themselves, while not fully liquid like water as we would think about it, are they still like is the structure of them? And this is very layman, so I apologize. I'm going to say it like this.
I don't know if I'll be able to answer it, but I'll do my best.
Is the bottom of that, I'll call it a proto-structure, more like attached to the ice and the top is wobbly? Like I'm almost thinking in a dumb analogy, like grass in a field. Like grass on top,
I got what you're picturing,
waves around, but the bottom is like rooted in something. Like
I think of it sort of like if you have a rough surface, like something that's like a bumpy concrete, and you put a bunch of bouncy balls on top of it, you're going to slip around. That's how I think.
Okay. I like your bouncy ball analogy more than my grass analogy.
Yeah. And so you're really just slipping around on those bouncy balls. However, if you're super heavy or it gets really cold, the bouncy balls aren't as slippery anymore. Or you push down on the bouncy ball enough that it's just not going to be slippery. And so it really is about, even though I sort of said it wasn't, it's really about pressure, the speed at which you're plowing through those bouncy balls, or in this case, water molecules, and the friction that those molecules are putting on the thing that's slipping by them.
Okay.
Yeah.
I think I understand it as best I can while discussing it and not seeing 1,000 intricate drawings of what this looks like. I think I do get it, though. And I like that the answer is both everything I learned is wrong, but also at a certain level leading you in the direction to the correct minutia of the problem.
Right. So, yes, I think that's exactly right. Had John Jolly not, and Faraday and Thomson and Kelvin all put together all of this kind of old stuff in the 19th century, and we tested it throughout the 40s, 50s, 60s, and so on, we probably wouldn't have gotten to this point as easily. And if, we hadn't come up with all the rules of friction in a completely separate science, we wouldn't have been able to put them all together.
Yeah.
So we really needed all of those people to do all that science first. The most concise way I've found to put it together, why is ice slippery? Ice is not. But the water molecules that sit on top of it roll around underneath your foot or your ice skate, reducing the friction between you and the ice, allowing you to slide around like a bunch of molecular ball bearings.
Yeah, they fill in the cracks, or not the cracks, but they fill in the rough patches around the structure of the ice, which causes it to be slippery, or causes you to slip. Let's say that, rather than causes it to be slippery, because it's two different things we're kind of talking about here.
Yeah, it's true. Ice is, I think, why is ice slippery? It's not.
All right, I'll take it. I like it. Thank you for doing all that. You have answered what I would consider one of my few lifelong questions.
Oh, wow.
Ever since I was a kid, it was something that, again, like we said, scientists do every 50 years or so, being like, oh, it's kind of this. Wait, no, it's not. Well, this is too hard. What else we got? That's kind of where I was.
We got to go to the moon. We don't have time for this.
Yeah, exactly. Punch Nazis. Thank you for solidifying that answer.
Hey, with that pun, I think we'll take a quick break. And we'll be right back to answer your question. Julian, give me your best dinosaur roar.
Oh, God, an asteroid! It's horrible!
Wow, that was not where I expected that to go. We're popping in before the show to tell you about I Know Dino. It's a dinosaur podcast.
We think of those dinosaurs being this thing that's been dead for tens of millions of years. Even so, studying dinosaurs can still teach us stuff that is relevant to the world today.
Yeah, like climate models to help us understand global warming.
Migration patterns of dinosaur lineages, they tell us about Earth's changing continents.
We can also study dinosaur diets, what plants lived then, and maybe what animals and how they interact.
And, this is super cool, many dinosaur injuries, paleopathologies, they're the first known occurrences of diseases.
And they talk about all this kind of stuff on I Know Dino. It comes out every week with new dinosaur stories that you're not going to hear anywhere else. Like, I hadn't heard of a lot of these, which is pretty cool.
You can find I Know Dino on Apple Podcasts, Spotify, wherever podcasts are. And if you found us, you can probably find them. Go check them out.
Welcome back, everyone, to That's Absurd. Please elaborate. I'm not the person you normally hear. My name is Matthew Krol. I'm the showrunner, narrator of Extra Credits, guest of Mr. Trace, who is one half of the lovely crew here. He asked me to see if I could bring us back, and I think I did.
You did great.
Oh, good. Great.
Yeah.
Awesome.
Well, so now that we're back, you have a question.
I do, but I'm going to ask my first question again. Is Julian at NASA designing different ways to find all of those various ice phases that we have just discussed in the first half of this show?
He's not. God. But he did get to sit in a fighter plane today, which I thought was pretty cool.
Man. Okay. Yeah. He wins.
Yeah, he wins the day.
So, no, you brought me this question from one of your lovely listeners, Cole Z.
Hang on. We've got a message here.
Oh.
Hey, Trace and Matt. It's Julian, long-time host, first-time listener. I am out at Edwards Air Force Base participating with NASA's NCAS program. Couldn't be there to host, but I still wanted to participate in some way. So Cole from San Diego asks, what actor has died the most in movies? Cole adds that he thought of this while watching Highlander, the weird time travel movie about an immortal Scottish guy, and just wanted to know who in total has died the most in movies, and how'd you figure that out? All right. Take care. Have a great show. And can't wait to hear the answer, Matt.
I hope he recorded that in the fighter plane.
Me too.
That would be
I
great.
do too.
I just picture him dressed like Maverick, like just chilling real quick before takeoff. Oh, that's awesome.
What would Julian's call sign be?
Oh.
I think I have a couple ideas.
I mean, it can't be Iceman.
No. I think it would be Lollipop because he's got a kind of a skinny body and a really big head. So maybe like Lollipop.
Okay. All right.
That'd be funny. It'd be funny.
Well, I think I'm the right person to answer this question for two reasons. One, for, again, that erroneously titled podcast that I am a co-host on with the illustrious director, Mr. Shahir Dowd, entitled The Only Podcast About Movies. There is only one, at least in this universe, that we've found. Sometimes we get guests from other universes that apparently have other ones. We don't know how that works. No, they're great. Yeah. I wish more people would start movie podcasts.
I just meant other universes. Other universes smell.
Well, they definitely have a different. They don't all pass the vibe check, but I talk about movies a lot on a weekly basis, and I obsess about questions like this quite a bit.
Yes.
So what I found, I looked for a bunch of different sort of ways to attack this, and I'll actually, here we go. Let's do the weird ones first. First, I wanted to do the vibe check, because when this question was presented to me, I was like, Sean Bean. Sean Bean is the person who has died the most. It has to be, because that's the joke.
That is his thing.
That's the meme. Like, of course it's Sean Bean. Why would the internet be feeding me all of these things if it weren't true? It is very much not true. Sean Bean has only died 24 times on screen, and that's about a fourth of the pieces that he has been in. So,
okay. So he only dies in his films about 25% of the time, because I would have guessed it would be like 100% of the time.
I know, and that's sort of the what's the Mandela or the Mandela effect of a certain thing. Yeah. Bernstein Bears. But I think that's just sort of meme culture taking a hold of this question, and maybe this is my other thing. Maybe he's just real damn good at it. Like maybe he's just the man you go to when you need an effective, memorable death scene.
You're like, oh, I'm going to love this character, and when they die, I'm going to be so sad.
Yeah.
Well, we got to call Sean Bean.
And then I started sort of branching out a little bit, but I wanted to look at it from, okay, well, let's think about not just actor, but character deaths, because I made this way through two films in particular, both Groundhog Day, the Bill Murray vehicle, and Edge of Tomorrow, or Live, Die, Repeat, depending on what time period and place in the world.
I prefer the latter title. I think it's just better.
Tom Cruise, Emily Blunt film based on the manga. And so I thought that maybe Bill Murray's character would have died the most on screen.
That does make sense.
But he didn't. He only dies roughly, it's actually pretty clear, but you could debate one of them, 12 times on screen in that movie. Though the film is supposed to take place over something like 33,250 days with a total death count of like, because sometimes he goes to sleep and resets, but the total death count in the story is like 12,395 or something. But that's not on screen.
Oh, wow. Yeah.
Right? So then I was like, well, what about Tom Cruise? What about an Edge of Tomorrow? And I think, from what I've found, his character has the most on-screen deaths, with a total of also 24, matching Sean Bean's character count. But this is one character in a movie dying 24 times.
If anything, Sean Bean's still winning on that, because
so
many movies.
I'm stretching the credulity of the question, but I wanted to explore this from a couple different options, because eventually I came across a wonderful article on Collider that actually answered this pretty definitively, and I have a list of the top 15 actors and their death counts. And an interesting question that I wanted to figure out at the end of it, because there is a definitive answer to this that we will get to. But definitive answers, as we've learned with ICE, sometimes are not enough for me. So at the 15th spot is Max von Sydow. Are you familiar at all with him?
No, never heard of him.
So he died actually in 2020 at 90. This dude was in a lot a lot of movies. And basically, he was in The Seventh Seal. He was in The Exorcist.
Oh, I see. I Googled him. I
Minority
know who he
Report.
is.
So he has 26 deaths. Okay?
He's in Flash Gordon.
Yeah. So he even at number 15, he beat Sean Bean.
Wow.
Okay?
Wow.
At equal, it's funny. I was trying to figure out why they list them like this, and I think it's based on number of films. At 14 is Christopher Plummer. He also has 26 deaths, but he died at 91 in 2021.
So far, here's what I'm picking out. Longevity is an important factor here.
Oh, so yes.
The longer you've been in the movies, the more likely you have died on screen repeatedly.
But I cannot wait to get to some of the later ones because it gets weird.
The way you're so excited, I could tell that matters, but similar to pressure on ice,
right.
It might not help me answer the question.
No. So I'm going to go through these as quick as I can, but also if there's any of these that hit for you, Trace, stop me and we'll talk about them. So
I will.
Jack Palance died 28 times in films. He also passed away in real life at 2006 at 87. I promise you all this data is important. Mickey Rourke has died 28 times. Mickey Rourke is still alive in real life.
Wow.
Michael
28.
Biehn, 29 times. Michael Biehn from the original Terminator fame and a couple other things. And Aliens, that in Abyss. Yeah, he was in a bunch of stuff, right? Mark Hamill takes the number 10 spot at 30 times.
What has he died in so much?
Oh my gosh, he's well, obviously, spoiler alert for the best of the new movies, The Last Jedi. He just a ton of stuff. The Guyver, Big Red One. He's just done it a lot, and I think because he's in a lot of small things that we wouldn't realize as he's gotten older. I think that's where all of his stuff comes from.
I totally forgot that he was in The Guyver, which is so good.
Yeah,
we used to watch it late night on the Sci-Fi Channel when I was a kid.
Yeah. It was awesome. Super fun. Number 9 spot, Bela Lugosi, classic, also died in 1956 at 73, but he died on screen 36 times.
Interesting.
Someone who I wasn't familiar with is number 8, Eric Roberts, who died 38 times.
So one thing quick about Bela Lugosi. Do you know who Bela Karolyi is?
No.
He was the Hungarian-Romanian coach of the U.S. Olympic gymnastics team. And I did once convince a friend on a road trip before there were internets that Bela Lugosi was the gymnastics coach for like the gold medal Olympians. I was like, no, Bela Lugosi. He was he coached Carrie Strug. She won when she hurt her chin, she won that gold medal, and they were like totally convinced.
That's always fun when you can do that. When you can trick someone so deeply that eventually 3 years later they'll bring it up at a party and they'll get into an argument about it. I have been on the receiving end of this. I'll do a quick tangent. Once upon a time when I was a teenager, my father told me the lead singer of Pearl Jam was named Eddie Bedwetter. And I'm like, that's stupid. No, it's not. And he's like, yeah, it is. It's Eddie Bedwetter. Isn't that crazy? And I was like, oh, okay. Then I didn't think much about it. And in my head, because I didn't talk about the lead singer of Pearl Jam a lot, I just kept that away. Then I was at a college party in my sophomore year and I brought up someone brought up Pearl Jam and was like, oh, isn't it crazy that it's like his name's Eddie Bedwetter? That's nuts. And they're like, no, it's not. I'm like, yeah, it is. My dad told me.
My dad told me it was.
And we had to go to a computer at the time because I'm that old and prove it to me. And then I called my father the next day and he could not stop laughing. Doing tricks like that are effective if you are the person A in that A-B scenario.
Yeah, luckily I was the person A.
Right.
I hope that they went on to argue with somebody about the U.S. women's gymnastics Olympic team and the name of the coach, who is Bela Lugosi, not Bela Karolyi.
I am sure they did. Eric Roberts is probably most well-known at number 8 for 38 deaths. He was in The Dark Knight. He was one of the gangsters in court. He was in The Expendables, a couple other things. Lance Hendrickson, obviously classic. 41 deaths on screen. He was obviously, in Alien 3. Now, here's where it gets interesting.
Okay.
Danny Trejo at the number 6 spot with also 41 deaths, but he's 79 years old. Looks great for 79. At number 5.
Yeah, he does.
At number 5, Boris Karloff, who passed away at 81 years old at 1969, who has 42 on-screen deaths.
That's a lot of on-screen deaths. What's he dying of?
Just wait.
What is he dying of that he's dying 42 times?
Just wait. It gets weird.
Because I thought there were action movies in the...
Yeah. I thought that these were going to taper off as we got up, like they wouldn't get as high as they did. I was wrong.
Boris Karloff was born in 1887, and he died on screen 42 times. This is the opposite of what I would thought.
Right?
I would have thought that, like, the 80s, the height of the action movie, summer blockbusters, all of this, there would have been so many deaths.
Don't know why. Number 4, John Hurt, who passed away in 2017 at 77 years old. 43
Wow.
deaths on screen. Obviously, Alien, Snowpiercer, Elephant Man, there's tons of others.
V for Vendetta,
Yep.
which he does die in.
See? Number 3.
Maybe he just played a lot of really disliked people.
Yeah, that's the other thing.
Everybody was like,
That guy
we
gotta
need
go.
to kill this guy before the end of the movie. We just gotta get rid of him.
Number 3, Vincent Price.
What?
Vincent Price died on screen 48 times. He passed away in 1993 at 82 years old.
How many movies was he in?
More than 48. I don't know off the top of my head, but I always remember him from Edward Scissorhands. That was sort of my my memory mostly of Vincent Price, other than his voice in a ton of different things.
Yeah. I quick Googled it, and it says more than 100.
That also makes sense.
True. But let's assume 100. He died in almost half the films he was in.
Sean
Even
Bean.
if it's 150.
Sean
he
Bean,
died
eat your
in
heart
a
out.
third of the films. I mean, that's just... Yeah, take that, Sean Bean.
Right.
Down there with only a quarter of your work.
Yeah, step it up, Bean.
Bean?
Okay, number 2, someone I did not expect, Dennis Hopper, who passed away at 2010 at 74, also 48. 48 times Dennis Hopper passed away on screen.
I mean, in the documentary Waterworld, he did. I mean, he deserved the future documentary Waterworld.
My question should have been about Waterworld. I think can we change it? Can we go back?
Waterworld is a film that I saw when it was in theaters in 1995. And then went to school the next day. And someone was like, what'd you do yesterday? And I was like, I went to a movie. And they're like, what'd you see? And I'm like, I don't remember. And I literally could not. It took me half the day to remember the movie that I had seen.
Yeah, it kind of just washes over you, wouldn't you say?
Hey!
Do you care to guess, Trace, with all of those names that I have said, what the number one person who has died the most on screen in cinema is?
I have Frank Sinatra.
No, he didn't even make the list. Christopher Lee.
Wow.
Christopher Lee, obviously, he passed away in 2015 at the age of 93. Do you want to guess his number of on-screen deaths?
So what was that? What was number 2's? 48?
48.
Dennis Hopper and... Okay. I'm just going to go like a little more. So like 52.
You ready?
Ready.
70.
What the? Christopher Lee, stay alive.
Now,
get some Bee Gees in you.
I don't know. It just seems it seems so mind-boggling. I tried digging it up. I couldn't figure out like what, if it was like maybe some filmed like theater performances or something like that, but there's no real data on that. But here's where I wanted to get a little wonky with it. So right now, Christopher Lee is in a hefty lead, and the next person in line who is still alive is Danny Trejo.
Oh.
Okay, now Danny Trejo has 41 on-screen deaths at the age of the real-life actor 79. Okay? Now, I believe he lives in Mission Hills, California. So that's L.A., right?
Oh,
is that?
He lives close to me.
Yeah, there we go.
Yeah.
So maybe you could go ask him this once we're done. Because I tried to look up, and this is obviously, there's so many different polls and data and stuff like that. I wanted to figure out how many movies Danny Trejo would have to be in and die in to beat Christopher Lee's record of 70.
Yeah.
So,
well, the nice thing is he could like have a cameo in a bunch of movies, like, right? You don't have to be a main character.
You can just, as long as you
show
die.
up.
Yeah. So I wanted to figure this out. So I was like, okay, what is like the average age of a male in that area of California? And it went a bunch of different sort of places. That it's 79 by most counts, which I thought was a little low. But then I was like, okay, let's assume that due to monetary compensation and lifestyle, etc., that your age is going to be a little bit longer than that due to having access to better medical care, let's say.
Sure.
So I wanted to use like the famous averages, right? So I averaged basically the list of the dead members in this list. Like I averaged how old they were to find the average lifespan of them. And that was roughly 83.1 years old.
Got it. So if Danny Trejo can make it to 83.1, he would hit the average of the death list.
So he would have to, by the time he gets to 83.1, he would have to die 30 films in the next 4 years before stealing the number one spot. Because, right?
Wow. Yeah.
That's 8.
He's 79. He has 4 years to hit the record.
Yeah.
He's currently at how many deaths? 40.
41.
41. And Christopher Lee has 70.
70.
Just 70 flat. Yeah. So he's got to do 39.
No.
29 more films?
29 more films to equal it, but 30 to beat it, right? I'm so bad at dumb, simple math.
He would have to do 30 deaths on screen to hit 71 deaths.
Right. So that means every year, Danny Trejo would have to do roughly between 7.5 and 8 films every year and die in them to beat the record.
I mean, or here's an alternative. Live, Die, Repeat 2. Starring Danny Trejo.
So I mean, but then you're only going up against Tom, whose character died on the same character died 24 times.
Right.
But I guess
so
you could
that would give you 24 deaths. That gets you, like, if you're just trying to juice the numbers.
No, you're right.
Just do a time travel movie where you die a bunch.
You are
Groundhog Day 2, starring Danny Trejo.
Danny, if you're listening, you could do this. And I love that, Trace, I didn't even figure that out. Trace, you figured that out right now, that it's actually not as crazy as I'm making it sound. It's only 29 deaths. In an hour and a half movie, hold on. In an hour and a half movie, no, movies are 2 hours. Movies are 2 hours these days. So let's say
120
minutes divided by, let's say, 30. So you have to die once every 4 minutes in one film. I mean, and if you count some montages in there.
Oh, yeah, I was going to say, in a quick montage, you could have 5 or 6 deaths in a minute. So really, that gives you a lot more story time.
Danny Trejo.
Wow.
I know.
You can do it,
I
man.
know you got Robert Rodriguez on speed dial, and that man can pump out quality work so quick. Get it done. I would like to see him take the death crown from, and I love Christopher Lee, but it would be really interesting to see that just sort of get beaten, I think. And
from dusk till dawn, live, repeat.
Right. Yeah.
Die, repeat.
Machete.
Live. Yeah.
Edge of machete. I think that's, yeah. Listen, I'll give him that one for free. I think it's a real. It has to be done. So
wait, he was in Minions?
Yeah, Danny Trejo is in a lot of stuff.
I love that man. I love him.
So Cole, I hope that answered your question enough, and with enough ridiculousness to it that at least it was beneficial for everyone involved.
I googled how many movies Christopher Lee was in. He holds the Guinness Book of World Records.
Yes, he does.
266 films. So we can do simple math. 70 divided into 266. He has died in a quarter of his films. He's on the Bean constant.
He's on the Bean constant. Absolutely. Yeah.
Like it's 0.26. So
yeah,
he's like right in the bean
range. Zone in the temperate bean climate. He's right there.
The Goldie Bean
Zone. I love dumb movie math stuff. And I'm so glad, Tracy, you gave me the opportunity to come on here and talk about it, because my co-host, Shahir Dowd, on the only podcast about movies, doesn't like my tangents sometimes.
Oh, this podcast is like half tangents. Yeah, come on.
By volume.
By volume, for sure. Not by pressure.
No. And the friction seems pretty light. So I think we're doing okay. Though I bet you it would be the most frictionless once Julian lands his fighter jet outside.
Yeah, we'll see.
Yeah.
Dang it, Julian. I hope you're having fun.
Hanging out at NASA.
Man, thanks for coming on and answering that question. It was just sitting in our database for so long. Cole, you asked that question so early on in our podcast journey here. I'm actually going to go and look it up when he asked.
Is it longer or shorter than Danny Trejo has on average to die in one film 30 times?
So we launched the podcast in April. He asked it in August, so just a few months in. Okay. We're almost at a year. So he asked it in the first. Oh my God, he asked it in the Bean Zone, the first 25% of our podcast.
All connects. Oh, it's perfect. It's perfect.
It's not quite the Bean Zone, but that's still fine.
It's bean adjacent.
Bean adjacent. The hopper.
Yeah.
The hopper.
The hopper continuum.
Yeah, Hopper doesn't go with...
No.
Bean Zone works so well.
It really does.
Oh, man. Well, thanks for asking that question, Cole. And thank you for bringing the ice slippery question, Matt. That was really helpful.
Of course.
Because I had a lot of fun looking into that. Because as soon as you ask it, it's one of those where now you've asked it. Now I have to know.
Right.
I just have to.
Yeah. This was an absolute blast. Thank you so much for having me. It's always an absolute pleasure to chat with you, either in a podcast-like form and I feel like the only other times I've really seen you is around pools.
Pools and occasionally a meal.
Yeah. Sometimes by a pool.
Well, yeah, you can do both of those for sure. The Venn diagram of pools and food is one of my favorites. As long as they're not right. You don't want to get right in there.
No, because that gets...
You don't want to be
right
in the pool eating necessarily.
Anyway, thank you so much for having me. This was an absolute blast.
Oh, my pleasure. And where can people come find you other than the only podcast about movies? You mentioned Extra Credit. Is this all something they can find on YouTube? What about you on social? Tell everybody.
So Extra History and Extra Credits are all on the YouTube machine and the Nebula machine. The only podcast about movies can be found wherever you get your podcasts from. Also on Nebula. Also no ads. I'm sure Trace has talked to you about that before.
We have, yes.
Use their code here this time if you're signing up for Nebula.
It is in the show notes.
There we go. See, there we go. And you can find me across all the socials that I check sort of regularly. I am Emperor MSK on Twitter, though I'm trying to wean myself off that. I'm also just Matthew Krol on Blue Sky. If you'd like to say hi over there. I'm trying to... I need to follow and check out Blue Sky more often, because right now... because I thought it'd be funny, and I really appreciate the work that they're doing. There is an account that I follow called Possum Per Minute, or Possum Every Minute. And all it is a new picture of a possum every minute. Now, at first, you're like, that's great. But I don't follow enough people, so my entire thing is just possums. And I'm mad at it, but not really. So if you say hi on there, I will follow you back, because I need to wean out these possums.
You need to just like dilute the possum
population.
Yeah, that's so funny.
But that's where I'm at.
I am also on Blue Sky. I think I'm at Trace Dominguez. I might not be. Maybe I am. But I'm at Trace Dominguez everywhere else, on Threads or on YouTube or on... I am on Twitter, but I also don't Twitter anymore. Thanks, Musk. I really used to like it.
I used to love Twitter.
It was my favorite social network until it wasn't. But I also would like to thank all of y'all out there for listening. You're listening, by the way, in case you forgot the name of the show during all of this banter. That's Absurd, Please Elaborate. The show was co-hosted by Matt Krol today, but it was written and produced and created by me, Trace Dominguez, although I didn't write Matt's answer, so that doesn't really work. And also Julian Huguet helped create the show. It's produced and edited by the wonderful and wonderfully talented Kyle Sisk. And of course, special thanks to Cole and Matt for bringing their questions today. If you want to submit a question, look in the show notes. You can email us at hello@that'sabsurdshow.com or go to our website, that'sabsurdshow.com/ask. We wouldn't be able to do this podcast without your questions, and we do read all of the questions that y'all submit. Cole's sat there for a while, since August of last year, but we really do want to answer them. So keep asking them, even if they're not totally sciencey. We love those just as much. So finally, also special thanks to those listening on Nebula. Nebula listeners get ad-free versions of the episodes there on Nebula. You can join with a link in the show notes if you haven't already. And remember,
in this universe, there's only one absolute. Everything freezes.